Hello, everyone, and really happy to be with you today in this one another technical session. Always happy to be with you, share the knowledge, speak about the technical things. And today is going to be live from New York. So it's noon here in New York. It's we're looking for the best time for our community. In Europe, it's 7 or 6 p.m. For our Indian friends, it's maybe a little bit late, and for Australia, Japan, and New Zealand users, so we have the recording. We are going to share the recording, and it's going to be live both on YouTube and LinkedIn. All right, so today we'll be talking about the everything secrets. And everything like related to the security in the cloud in general, and specifically security in infrastructure as code when we manage infrastructure with code. And so let's get started. Quick words about me. I'm Shafiq. I'm the founder of Brainboard, and I've been working building cloud infrastructures for the last 16 years. And before that, I was CTO of a French cloud provider called Scaleway. And so today I'm building Brainboard along with the team. So, and Brainboard is sponsoring the event. So quickly, what Brainboard is a solution that allows cloud architects, DevOps engineers, platform engineers, even developers and technical managers to visually design and manage cloud infrastructures. And this is like a way to build the infrastructures the way you think about it, and generate the Terraform code, build pipeline, and manage the infrastructure the way you want. I will be doing the workshop with the Brainboard because we built, almost all the security aspects that I will be talking about with the Brainboard. So it's going to be much easier, especially that we have 45 minutes today. All right, so what we'll be talking about, this is like just a summary, not in a specific order, just to give you a glimpse about what we'll be talking about. It's sensitive information and security and how to manage the secrets in infrastructure as code. And this is a relaxed, you can say, conversation and presentation. So feel free to ask any questions in the chat. The team will be taking the question, and I will be doing like breaks just to answer the question, and and this is the goal also of the webinar, is to share the knowledge, learn from you, get your questions, suggestions, and spend a very good time together and learn, and that's perfect. All right, so okay, so this is what we'll be talking about today, and before we start, so the goal of today of the webinar is really to show in real world how security works when you work with IaC. And the main goal is to bring awareness, because now everyone is building infrastructure with code or willing to do it. So, and everyone, we are seeing a lot of adoption of Terraform. It has been around for more than 10 years now. We'll be also sharing the best practices. What are the best practices, the pitfalls, a bit of discussion around this. And the most important part is not just theory. We're going to jump into building a real use case and see how it behaves and what are the different aspects. So, and as I told you, I will be using Brainboard. I'm going to explain it a bit, but all the aspects are applicable to any to infrastructure as code in general, not to a specific tool or a product. All right, so the first thing is just here to remind the scope when we talk about the infrastructure, cloud infrastructure in general, and what people mean when we ask this question, the cloud infrastructure. And I'm seeing some of the users that our friends, hi Lalit, really happy that you joined today. So yeah, so when we ask the engineers to define what the cloud infrastructure is, usually like we hear a lot of questions, we hear a lot of answers. Like it could be, it's just the provisioned resources in my cloud provider, or it's just my Terraform code. So the first thing that we would like to remind you is that the cloud infrastructure is not just a bunch of Terraform files. And this is like we've seen this, especially the last, you can say, 2 years, where everyone is talking about Terraform and infrastructure as code, and we forgot, like we just keep focusing on this, and the infrastructure becomes just Terraform. And I would like to highlight a very important aspect about this when we talk about the infrastructure in general. There are different parts that are involved in the infrastructure that should be considered as part of the cloud infrastructure. And so the three aspects are extremely important: people, process, and tools. For a lot of reasons. People are going to build a cloud infrastructure, so they are, if they do mistakes, people are behind the mistakes. If they have a learning curve, they need to learn. And they build the process that allows them to create the cloud infrastructure, scale it, manage it, replicate it, have strategies, secure it, and so on. And they will be using tools. So the tools will help engineers to build cloud infrastructure the right way and have the process and captures the process sometimes. And so all these parts are related to each other's. And usually these three parts are hidden, are not visible. So here, understanding the holistic view of the security should include these hidden parts that we usually don't talk about. All right, so now let's zoom a bit and let's talk about, okay, we zoom to understand what the cloud infrastructure. So, and what's the anatomy of the cloud infrastructure. And here again, some of you can say, when I need to build cloud infrastructure, I just jump in and start building the cloud infrastructure. Some of them say, okay, I want to think before I do anything, so I need to design a diagram, then I'm going to build it and deploy it. And these, like the first important aspects are thinking before developing anything is the blueprint. I want to do the diagram and to understand what's the relationship between my components, what I need to build before I start writing Terraform code. Or I mean, it could be any code, not just Terraform, but it's applicable to anything. And this is also, it's extremely important also in terms of communication. You're not going, as I said, when you have different teams, you're not going to throw just Terraform files on different teams and let them manage it and understand it. And this is an extremely important piece when it comes to securing the cloud infrastructure. Okay, once you do the blueprint, you're going to translate it into code. It could be Terraform, it could be Pulumi, it could be SDK, it could be Ansible, whatever the code it applies. So when it's converted into code, you may use the secrets, sensitive information as a general word. It could be passwords, certificates, secrets, whatever. So you are going to use them. We're going to see how and how to secure it. So, and once you build, maybe part of your test is you build pipelines, and you build the pipelines for maybe for the test and also for the deployment. And the end game is to deploy the cloud infrastructure, which means create physically the cloud resources at the cloud provider. So with this work, with this workflow, you also need to understand who has access to what and why. The why sometimes is not that obvious to track. We need an external system to track it, but the access is extremely important in this workflow. And also traceability, like who did what and when. And like this is extremely important, and not just in the code when you do the commit, not just in the pipeline, not just in the design when you review, but in the complete workflow. And for this to work as a part, for all these components of the cloud infrastructure to work in, we can say, in a good way, there is a very important aspect, which is like you need a source of truth. And this source of truth could be, it could be in the code, it could be in the pipeline, it could be in the head of engineers. This is one of the problems that we have. And like this is the first best practice that I will share with you. And as you can see here, people are involved. People, tools, and processes are involved in every aspect. So here, the first best practice when we talk about the source of truth is like you need a unique source of truth. And when I say unique source of truth, single source of truth, for a lot of reasons, and this is extremely important, especially when you have problems. Like when you have a problem, you will not be looking around, you will not be running all over the place, like asking your colleagues, because you know your colleague, because you know that only this specific person has the knowledge. You will be looking at Git commit, what happened, what caused the problem. You will be looking at the console, on the logs. You will be running all over the place. And this is, if you don't have a unique source of truth, you cannot scale the infrastructure easily. I don't say you cannot scale it at all, because you can scale it with a pain, but it's extremely important to have a unique source of truth. And also when you onboard new engineers, so you have a unique place to tell them, like, here our source of truth, and here all information you need to know, and all all what you need to understand about the infrastructure is in this place. And so let's move now into Brainboard quickly, because we'll be introducing these concepts like as we go. And the first part, when I talk about all these components that I showed you, like the blueprint, the code, the secrets, and so on, and how they are important when you put them all together. And this is, unfortunately, in the industry now, the way we do it, we use a specific tool for every part, and we switch between tools, which makes the learning curve a little bit high, because you need to learn different things. You need to learn maybe draw IO, Visio. This is pretty simple and easy. And then you need to learn a Terraform code with all the specificities. This is important, that you need to understand the secrets, the tools that you use for the secrets, then for the pipeline, and so on. So here, for example, I'm taking in this example of a landing zone and explain in a clear way, like, okay, this is the first component of my infrastructure. Before I talk about the code and any specific component, I can see, and this is a valuable asset in terms of cloud infrastructure. I can see here, this is like I'm having a public IP, I'm having a firewall, and I'm having here a Jamp host with different components, and then the Key Vault application gateway. And then, okay, I say, with this, I can investigate the code. I can see here deeper. I can say, okay, what's the firewall that I'm using? What's the configuration of the firewall and how I'm using it? We combine this with the secrets. We're going to talk about the secrets right after this, and how you secure the cloud infrastructure. And this is the second piece. The third piece is, okay, once I have this, I'm going to deploy this cloud infrastructure. So here you can move to the pipeline, and you can see, okay, I'm going to deploy this infrastructure, and I can see like every aspect of it before I deploy it. And then once the infrastructure is deployed, you can either check on the cloud provider. I just picked Azure. It works the same for AWS, for GCP, for any cloud provider that you use. It's the same principles. It applies for all of them. And this is extremely important. And having one single source of truth, it's like a way to bring everyone under the same understanding of the infrastructure, and there is no drift, even in terms of understanding the cloud infrastructure. All right, so I will be switching between Brainboard and the slides to depict my explanation, because I really hate theory. Even if I explain things, the most important part for me is really show how it works. Okay, so, and now, as we talked about the source of truth, so let's assume that you apply the best practice and you have a source of truth, a unique source of truth, and now you are using Terraform infrastructure as code to deploy the cloud infrastructure. Let's zoom now on the sensitive information in Terraform. And so the sensitive information when it comes to Terraform, like you have the cloud provider. So before you deploy, you need to have a valid cloud provider credentials. Every cloud provider has a different mechanism. You can, for this one, it's better to rely to the cloud provider mechanism. Like for AWS, you can use roles, you can use SSOs. For Azure, you can use AZ login, service principals, and so on. So it's better to stick to the best practices of the cloud providers and not reinvent the wheel, because Terraform uses works exactly with these credentials. The second part, okay, the second sensitive information is like what we call it secrets. It could be the secret, it could be a password, it could be a certificate. And this is usually it comes during the development. So when you develop, you can say, okay, for this database, I'm going to use this password. And we are going to talk later about like how you store the passwords and how you store the secrets and how to secure them. And you store the certificates. And once the infrastructure is deployed, the most important thing after is the Terraform state and the secrets put inside it. And the Terraform state is extremely important and sometimes is the weakest part in Terraform because it contains sensitive information in clear text. Yes, in 2023, the secrets are clear in Terraform. And I mean, the community, I mean, everyone building the infrastructure this way have different mechanisms to deal with it. This is extremely important to understand. Okay, so now that we talked about the secrets and the different levels of the secrets, let's see how you can set them. And you have different mechanisms to set the secrets. You can say, okay, let's, for example, I go back to my example, and you can say, for example, I explicitly take this virtual machine, for example, here. And this is, I can say, okay, here I'm going to, okay, when I open the configuration, I have the admin, let's look for the password here. Okay, the admin password. I can say here, I'm going to hard code the password. Like this is a very insecure password, 1, 2, 3. And here, when you do this, so it's going to be part of the code. And the first thing that we advise you to do, please don't do it even in development, because it's a habit. Like build this habit to think about security from the beginning, because security it's part of the design of the infrastructure, not something that you deal with it later. So this is extremely important. So you can say, okay, so I can hard code it. We do not advise you to do so. You can use environment variables like in Terraform, but it comes to the same thing. I can say here, okay, instead of hard coding the value, I'm going to look for the password here. I'm going to use a variable. Let's call it var my VM password. And this here, I'm going to say, okay, this VM password, my VM password, this is a string. All right, here string, and I give it a value, the password that I wrote. And in Terraform, you can flag it sensitive. So you can say, okay, this is a sensitive information. Brainboard gives me this possibility. I'm gonna put it as sensitive. So here, still, if you have, when you see the Terraform block generated for this variable that is called the VM password. So you can see here it's sensitive, and we put it into the TF vars. But the value is still clear. So here, if you check this code into Git, the value will stay clear. And this is not something that we advise you to do. Even when you put you flag the variable as sensitive, which means it will be hidden in the logs, in Terraform logs, but we do not advise you to do so because, I mean, it will be clear. And everyone who has access, not only to Git, but also to the logs, like, for example, or the commits can, or any, the system access into Git can see this. It could be in the backup as well. Yeah, and this is something that extremely hard to deal with once it's out in the wild. So the other part is you can use vaults. And when I say vault, I'm not referring to HashiCorp Vault only. It could be any secret stores. It could be, for example, KMS in AWS, Azure Key Vault. It could be HashiCorp Vault. It could be any external vault that we want to use. And we're going to do, I'm going to do a use case on this. We're going to build infrastructure together and use, for example, a key vault. And then we can see in AWS, if we have time, in KMS, how it works and how you can define it. And the other part as well is, the other option is you can define it in the pipeline. But the pipeline is just like an automated way to fetch the secrets. So you need to store them somewhere. It could be in the environment as an environment variable, which means shell environment variables for the runners within the pipeline. And here this is one of like the most used things when you inject the secrets into the environment, especially if it's ephemeral. You can say, okay, this is within my container. I use the secrets as an environment variable, then destroy the container completely. And this way there is no log, the secrets are not stored anywhere. And the last option, and this is extremely useful as well, and I've seen a lot of teams using this as well, is to encrypt the secrets. And you can encrypt it with different mechanisms, with SOPS. These are different tools. SOPS is an open source tool. You can encrypt it with KMS, with Vault, with Key Vault, with any encryption mechanism. And you can say, okay, once it's encrypted, I can now store it into Git. Because I know that I can decrypt it, and I'm only the only one who knows how to decrypt it. This is like a valid option as well. But the most important thing is, I mean, when you work with the encryption, it needs a high level of knowledge of how encryption works and how you manage it and how you maintain it. And usually, I mean, it's a team effort. It's not one person. One person can manage it, but you cannot scale it. It's a team effort. So that's why I think the best option is using the native mechanisms of like in having secret stores. Okay, so now let's zoom inside as we are building it, building like the cloud infrastructure and talking about the secrets, and we are going to do secrets. The first thing that the best practice that I really want to highlight before we dive in is to keep your environment isolated. So if you have, for example, dev, staging, production, or whatever the environment, please keep them separated, isolated, for a lot of reasons. The first one is to reduce the blast radius. In case you have, for example, an issue in the development, the secrets have been leaked for the development, it's not the same as production. And for a lot of reasons as well, maybe you are doing a change in the staging, it shouldn't impact the production, it should be isolated. And when I say isolated, it's not just in terms of secrets, in terms of life cycle. It could be secrets, like lifecycle in terms of change into Git and like the complete change. It is also, it concerns also the Terraform states. So like to reduce, this is what I call reduce the blast radius and reduce impact. And also the benefit of building the infrastructure this way, keeping it small and keeping it isolated, is also when you do Terraform, the refresh in the state will not take like an hour or two just to refresh the state when the infrastructure is big. And this is, I mean, it's not a joke. I've seen infrastructures where the refreshing the states takes 2 hours, literally. So there are a lot of benefit out there. And you have different strategies. We have already talked about this best practice and how you can do it. You can use Git branches for to isolate the infrastructure. And this is important when it comes to packaging the infrastructure as one stack. It could be for the application or as in just an infrastructure. If you package it as one stack, then you need to separate it. It could be Git branches. It could be Terraform workspaces. If you are using Terraform and Terraform Cloud, for example, this is extremely useful. It could be separate folders in the same repo, or it could be, if you are using Brainboard, it could be Brainboard environments. So this is what, actually, we put these best practices within Brainboard. You can say, okay, now I have my environments. I have, for example, this is project that contains environment. I have my dev, staging, production, and so on. And for example, this infrastructure that I'm building here, this is the landing zone. So I want to keep it isolated. I want to create a copy in a target in another environment, let's say production. And here I can synchronize them, keep them synchronized, but isolated, which means any modification that I do to any environment, let's say, for example, here I'm in production, I can see the sync between environments. And by the way, I'm showing this in Brainboard. It works the same. If you are using TerraGrunt, it's the same principle, like having this different environment that share the same architecture, but isolated with TF vars. We implemented the same mechanism in Brainboard. It could be the Terraform workspaces. It's the same. So here I can see all my synchronized environment. So here I'm working in production. which means any modification I do, let's say, for example, here, I want to add a container, let's say, a container app here. Let me add container app here. And now, for example, I give it a name. This is var.container app name. So here I have the same design, and in the container app name, okay, yes, here, it's the same. I can say this is a variable that use a string and has a value production because I'm now in production. So now if I switch to the other environment, you should see the same change. So here I'm in the other environment, it's the same change, the same variable, except that now I'm going to change the variable name. So here I'm going to put development. All right, which means now I have the same design of the architecture, but isolated with the environment, and we do it the same, exactly the same way as TerraGrant does. This is a great idea. So in the Terraform, the TApp vars, we separate the values. And the most important thing in terms of isolation is that you manage the remote backend. You say, okay, I have two separate architectures, but two separate environments for the same architecture, but I want to separate the Terraform state of every environment. So you can go to development and specify the remote backend that you want to put. Let's say I want to put it into specific S3 bucket for the infrastructure or blob storage. I'm talking about Azure. And I'm going to go to the second replica, the second synchronized infrastructure. Here, I'm going to move into production, and I can say, okay, now in production, I'm going to use another remote backend, which is, it could be, blob storage or S3 or Terraform Cloud or Brainboard, whatever the remote backend. There are a lot of remote backends supported by Terraform. And this way, like, you do not repeat yourself. You build the infrastructure once, and it will be synchronized across all the environment, which means, and this is extremely important in terms of minimizing the drift, because when the drift happens, a lot of troubles come with it. And one of the troubles is the secrets, because you need to keep yourself consistent across all the works. So yeah, this is extremely important to isolate the environments. So, and now talking about the state file, I just talked about it quickly. The state file also should be isolated. And the best practice in terms of security is to isolate the Terraform state at the layer, architecture level, or the layer level. Maybe, for example, you are building an infrastructure in stacks. This is like a lot of teams are doing this. You can say, okay, I have a stack for, it could be infrastructure-oriented stack or application-oriented stack. It can be, for example, I have a landing zone, AWS, GCP, Azure, they all like work similarly. I have first the networking part, then I have the compute part, I have a storage part, I have a DB part, or I have microservice 1, microservice 2, microservice 3, and so on. And I have them in stacks. So every stack should have its own Terraform state for all the reasons that I mentioned before. And this is like, we built Brainboard this way. So for example, if I click on any infrastructure, here it has exactly it has its own Terraform state that is separated from the other layers and architectures. Another aspect also to secure in the Terraform state, and of course, I'm talking about the state because it's related to the secrets, because this state stores the secrets, as I said, in clear text, in plain text. So, and not everyone should have access to the Terraform state. And I mean, this is more like a bigger point, which is you should not be deploying the infrastructure manually. You should be deploying infrastructure in an automated way, like through the pipelines, with an approval system and so on, which means the only one who has access to the Terraform state should be the runners from the pipeline. And this is something that you can control when you choose the backend. For example, if you choose S3 or Azure Blob Storage, this is something that you can set. And also, and if a human needs access to the Terraform state, I mean, this is like for a specific purpose. And just to share with you, like in Brainboard, we have more than 30,000 users using Brainboard. And like we received a request to be able to verify or access the Terraform state only from 10 users, less than 10 users, which means like it demonstrates how like using automation, when you use automation, you usually don't need to access the states. There are some edge cases where you need, but I can say as a general rule, you don't need access and you need to plan for it this way. The other point about the states is the encryption. So again, as it's plain text, you need to encrypt it, and you need to choose the backend that supports encryption. And now, like almost all the backends supports encryption. This is something that you can set at the backend level. For example, here, if you want to use, let's say, an Azure remote backend, blob storage as a remote backend, we already have here an architecture. I can show you quickly. For example, remote backend. Okay, for remote backend, you can say, okay, I'm going to build this architecture. So I have a storage account with a storage container, and I'm going to put in the configuration of the blob storage the encryption. So I'm going to put the encryption, I'm going to put versioning, I'm going to put everything, and you create the blob storage in a way that is encrypted by default. And also the last point is when it comes to the remote backend that you use, you should use versioning. And this is like you need to care about and to think about the backup. Like how are you going to version and backup the infrastructure? Because it's extremely important in case you need to roll back. Especially, and this is a very important part, guys, when you work with the infrastructure as code and Terraform, because you are versioning all the Terraform files in Git. This is a lifecycle, and the Terraform state has a different lifecycle. So that's why it is extremely important to understand to version, because in case you need to go back and restore any file or like, restore any Terraform state, at least you have the versions available that you can restore from them. Okay, so this is, yes, this is about the Terraform states. And as I told you, like, yes, you can do everything with code. Even the remote backend, you can create it with infrastructure as code and with Terraform. And once it's created, you can say, okay, now I'm going to go back to my architecture. The architecture, any infrastructure that you have. And you can say, okay, now I'm going to specify the remote backend that I just created here. I can say, okay, I need my remote backend, my blob storage. I'm using Brainboard to depict, but it's exactly, we generate the Terraform code. So it's exactly the same thing that you do in the code. And once it's done, so you will be using this remote backend. So here, I've been talking a lot, and I've been talking for more than 30 minutes, 36 minutes now. Maybe we can take some questions from the community. So I'm seeing like few questions coming. All right, so let me just quickly read the questions here and see if all right, so I'm reading here in the thread. Is it possible to learn where we can reach the sample templates? Yes, all the templates that, for those who are wondering about Brainboard, all the templates are in the templates catalog. So when you access Brainboard, you have here the templates catalog, and you can just search for any architecture and clone it from there. And yeah, so you can search for your use cases, and we keep building templates regularly. All right, some of you asking about the recording. Yes, the session is recorded and will be streamlined both on LinkedIn and YouTube. So you can find it there after the session. All right, I think that's, okay. Yes, and I see Nathan asking about OPA and the OPA and where it goes. Yes, very good one. Yes, Soren, thanks for the question. This is an excellent question as well. What's the recommendation size of stack? Brainboard thinks about the stacks. Yes. So the stacks, the way we build the stacks, and really happy to see you here, Soren, by the way. So you are an expert in Terraform, so you know, I mean, like, we would like to maybe have a session with you and share the knowledge broadly with the community. So here, the stacks, the best practice of the stacks is to keep them small. For like, the main reason is the Terraform state, because it's refreshing the state. It's extremely sometimes time consuming and time consuming and energy consuming, because you wait, then you go back, and if there is any error, you need to fix it after the state refreshes and the output comes out. So this is for this one, and also for the blast radius. This is, for me, the main reasons. We can include the third one, which is like for manageability and scalability. You want to create stacks in a way, and that was the initial idea of TerraGrant, by the way. They created it in a way that you can scale it through the different environment. Within Brainboard, the stack, you can put it into different ways. You can put, like, every stack is an architecture itself, or you can create a new folder for the stack. It depends for me on two things. The first one is, how do you work with infrastructure? Are you application-oriented or infrastructure-oriented? And based on that, you adopt the best strategy. All right, so I think we covered most of the questions. So feel free to keep asking the questions. I'll be checking them and answering them. All right. So now the next step is, what's the security landscape? All right. So before we go into the security landscape, let's build a use case about like how I create the infrastructure with the secrets and how I manage them. So let me create here new architecture, and let's start having a real example here. Let's call it VM with secrets. I'm taking a simple example, but it works exactly the same for any use case you want. This is, right. Okay, back, yes, VM with the secrets here. All right, so quickly, I'm gonna draw my infrastructure here. The purpose here is just to create like just a virtual machine with password, secret and password, and show you how you can use Key Vault and put it in the Key Vault. All right, so here I'm gonna take, all right, in my region, I'm using Azure, and hopefully, if the time allows it, we are gonna do AWS as well. So here I'm gonna quickly drag and drop my, resource group, and you can see here the Terraform code will be generated for me. It allows me to quickly webinar about secrets. All right. So here inside my resource group, I'm going to add a virtual network quickly. All right. So here I'm going to add a virtual network, and inside I call it webinar. Find it easily, and give it a valid address space. All right. So within this, I'm going to add a subnet. Yes, it's here. All right. So here I add a subnet. I call it webinar as well, and give it a valid value 024. And with this, I'm going to add here, and you can see the Terraform code that will be generated when I design the infrastructure. I'm going to add a network interface. So network interface. This is the network interface for the virtual machine. Okay, so here I'm going to add my network interface and say, okay, the location is US, and the name, call it Nick1. Give it the name Nick1 as well. And you can see here, these are all the parameters that are supported by Terraform and the cloud provider that you can use to quickly build infrastructure. And the location is dynamic. And for the subnet, I'm going to use the subnet ID. All right. So now I'm going to add Windows virtual machine. Okay. And here where things will start to get interesting. So here, when I add a Windows virtual machine, I have the admin password and username. We can say the admin username is webinar. And the password, so here, I'm not going to put it in clear. I'm not going to put it in any like non-sensitive way, non-secure way, sorry. So I'm going to just right after this, I'm going to show you how to do it. So here, webinar, network interface is I'm using this network interface. And let me just take an example of the virtual machine here. For the size, I'm going to take standard DSV2. So it's here standard VSD2. For the caching read write. All right, and here for the caching read write, this is for the disk and storage account type. For the storage account type, I'm going to take standard LRS. Of course, you can use variables, storage account type standard LRS. You can use variables as well. Here, I'm just quickly building it to show you how it works. Okay, I have I have my Terraform code and my infrastructure. So now I want to put the admin password from the key vault. So here I'm going to add a key vault and say, okay, I want to add a key vault as part of the infrastructure. And my key vault, I give it a name webinar. And so let me take a valid SQ here for the key vault. This is, all right, here for the SQ. I'm going to put standard here, standard. And I need a tenant ID. Okay, so here for the tenant ID, I'm going to switch into data and look for client config. Okay, that's one. All right, so I'm going to put it here. This is just a data object that allows me to read my subscription. Yes, my subscription, and gives me the information. So here in the tenant ID, I just type tenant. Okay, this is the tenant ID. All right. And now in the configuration, I can go deeper. I can say, okay, I want to purge production enable it to be true. And okay, and now we have the access policy. And I can say, okay, for the access policy, I can put, you can go deeper into the access policies. You can say the object ID comes from my subscription, and the tenant ID is the same tenant. Now I'm like giving the permissions on the key vault to only allow the runners that are running Brainboard to access to the key vault, and not everyone. So get list and set, that should be enough. Secret permissions, it's the same, get and set. All right, let me check here. Secret permissions, yes, for the key it's not set, it's create. Yes, Azure, right, different between create and set. And the storage permission is list, definitely list, and also for the storage permission and get as well. All right, so I am good here. This is the configuration of my key vault. So I have quickly everything I need. And now I'm going to say, okay, so I'm going to use a secret. So here I'm going to put a secret. This is a secret that I will be using in the virtual machine, and I will store it in this key vault. So here I have key vault ID. So this is the secret will be here, and this is we can say VM password. And for the value, again, I'm not going to hard code the value. So what I can do, so I can use a random password generator, and which is a valid Terraform component. So here again, I can go here. I can say, okay, I'm going to take this and give it a value of random password generator. Random, this is a random password. Here, call it like VM password. And in the Terraform code, what I want from the password, let's say I have, yes, I copy paste here. I want the length to be 64, and it contains special characters and at least two lower case characters and two uppercase characters. Okay, so this is it. And now within the secret, I can say, okay, now in the secret, all right, so now in the secret, in the value, I'm going to use random password dot VM password dot result. So here, nothing is starting clear. So everything, so here what I did, I have a random password generator. Let's call it random password generator with 64 character that will not be visible in the logs. Then I put it into the secrets in an automated way. It's not visible. I'm just referring to it here to its value as an output. Then put this secret in the key vault. And now in my virtual machine, I'm going to use the password from the secret. So here I go to my virtual machine, and I can say it's going to be the secret. So yes, here, and say dot secret. All right, so here we go. And now I'm going to put as an admin password my secret. Having that, so now I can say, all right, so I'm going to deploy this infrastructure. And now let me close this one and say, okay, now I'm going to do here in one action, I'm going to do a plan first to show you how it looks like in terms of Terraform. So now Brainboard, it converts all the Terraform code, all the design into Terraform code, and in a visual way, I can understand which is which. That this virtual machine is using this secret in this password, but also in the output, I'm going to see exactly this, and I'm not supposed to see any clear value for whatever I've built. So, and by the way, we do exactly the same Terraform command as the transparency. We show you exactly what we are doing. Okay, this is the VM password. This is in line. Okay, I think I created the variable, the VM name, VM password here. Okay, the name should it contain. Okay, let's characters and dash. Okay. This way, it may work. All right, hopefully there are some errors since it's a live one. Otherwise, you say everything is prepared, perfectly prepared. Okay, so let's see now the output of the infrastructure, how it looks like. Okay, here, unsupported attributes. My bad, this is not the secrets. Okay, in admin passwords. Oh, it's, sorry. Here, it shouldn't be the secrets, but here in the Windows virtual machine, it should be not a secret because it's secret, but it's value. So I'm going to put a value here. And this is extremely important, by the way, when you work this way, especially in Brainboard, you have the feedback loop super quick, which means if you have, this is like the shift left in the infrastructure as code, which means if you catch errors at early stage and you take the knowledge, what's wrong, and you integrate it into your workflow. And I see some of the questions talking about the drift and the CI/CD. I will show you this part as well. So now let's work on this to have it working. So here, the error that I have, Source image. Oh, yes. I need a source image, of course, for my cloud infrastructure, for my virtual machine. This is something that I didn't put. All right. So here I can go into the advanced configuration and look for, it should be by the end, source image. Okay. So let me take one of the, what I have here, Windows Server. So the publisher, Windows Server, the latest that was late, the version is latest, and the offer is Windows Server. And for the SKU, let me take here an SKU that I have. Let's put data center 2022. All right, and let's give it a try another time. Yes, and you can see, I mean, like I'm working on Brainboard. It's like I'm working on my, like locally on laptop. And this is extremely important to have like a remote place, like one place, central place, even for the team to collaborate. This is, I mean, we started Brainboard out of our own frustration, and we would love to advise about like these best practices and how we are using it, even us, to work on the infrastructure. All right, so now, okay, you can see here, this is the Terraform plan. I have all the output here, and I can see every, this is the secret, and you can say, you can, for example, the value is sensitive, it would not be shown. And in the virtual machine, so in my virtual machine, the password here is a sensitive value that comes from the secret, and nothing is shown. So now I can go ahead and can say, okay, now I want to deploy this infrastructure. I want to do like apply to deploy it. Or this is, I don't advise you to do apply directly and deploy it this way. It's better to build a pipeline. And you can say, okay, I want to build like part of my way of building the infrastructure. And this is extremely important for security, guys, is that you check the infrastructure before even you push into Git. Because, I mean, you can push into Git and use the CI to test. For me, it's not a clean way to work. It's better to test everything. And once you push clean work. So this is something that I can show you here quickly. Okay, let's say I'm going to build a pipeline to, before I deploy my infrastructure, this is my secure pipeline. So in part of my pipeline, I can say, okay, I'm going to start with Terraform validate. So here, code validation. And by the way, the CI/CD of Brainboard has been designed specifically for the infrastructure. So you see here all the plugins for the infrastructure. If you are running the CI yourself and or managing another tool, you can use these open source tools, of course. I mean, you need to manage them and maintain them, but you can use them. It is open source. And for example, once the infrastructure, once the code is valid, I can say, okay, now I want to do a security check. And this is, we use here TFSec, security check 1. And then I'm going to do another security check with TerraScan. Here, for example, security check 2. Specifically, if you use CIS, benchmark, and so on, TerraScan is based on that. You can, I think Nathan asked the question about OPA. So you can also define any policies, regos. You can write here regos, like I'm going to write here my policy, package Brainboard, then here, like write my rego and give it a decision. It's Brainboard/deny, whatever. And now once I build this, I can say, you can add the cost estimation or whatever, but the purpose here is to check security. I can say, okay, once this is done, I'm going to notify through email or DevSecOps, through email or Teams or Slack or whatever the mechanism that you want to use to notify people. You can say, please review the infrastructure. Here, send it to security@brainboard.co, send it to DevOps@brainboard.co, and you can send it to anyone who is involved in the infrastructure. After that, you can say, okay, now I'm going to deploy the infrastructure. I'm going to do Terraform apply. but I require an approval. Like for example, here our colleague Paul, our dear Paul, now he is the approver. And now when I do this, only Paul will be able to deploy the infrastructure based on the output. And if there is any error, the pipeline fails. And this is like a good way to deploy the infrastructure. What I advise you to do, to have these kind of security checks that allows you to catch any problems at early stage. And catch any, like all the problems, and you can shift left the real way. So you can, once you have an issue, and hopefully we will have an issue that I will show you like how it looks like when you fix it and when you run it back. So the first part is code validation. So once, okay, the code is valid now, the next stage will be triggered. And now, all right, so this one will be executed. Let's see what output of TFSec. Okay, I have a few errors. I have a critical one, as you can see. And this is extremely important. I can see, okay, what's the issue? My key vault ACL doesn't block access by default. And this is, as I'm storing the secrets inside, this is extremely important to know. So that's why these kind of tools allow you to scale and to protect yourself, because for a lot of reasons. And you have the information here. And by the way, this is, so Brainboard will give you exactly the same output of TFSec with the link to the documentation. You can open the documentation, you can say, okay, this is critical, why this is critical, this is an insecure example, and now I want to secure this. And this is how to do to secure it. You can go now into Brainboard or into your Terraform code and add this section in the key vault. So here is my key vault. And now in the access policy, so yes, in the network ACL, I'm going to bypass Azure services and deny everything. So here I deny everything except Azure services. So here the code will be updated, and now I can run the pipeline again. So I can go here, run the pipeline, and do the checks. And this is like, you can see, we are doing it live. It takes me just a few seconds to have like a production grade pipeline, have the knowledge, have the knowledge and the reason why it fails and why it's not compliant in terms of security, and how I fix it and go back. And I really advise you to use all these plugins, and you can use a Sneak, you can use a Palo Alto, you can use any kind of plugins that allows you to scan the infrastructure and know what the security posture before you deploy it. So yeah, so I'm going to do second iteration. And once all these infrastructures are green, you can go ahead and say, okay, now I'm confident to deploy the infrastructure. And once the infrastructure is deployed, you can say, okay, now I can do pull requests, I can update any ticketing system or any external system. All right, so here, this is like I hopefully talked about all the topics that I wanted to talk about. It has been an hour now. So yes, we did the use case of Azure. I will be happy to do the use case of AWS. Maybe I'm going to do another video for AWS and put it on LinkedIn and YouTube. So please, if you want to follow us and have the updates about what we are building, you can follow us on our LinkedIn page. And you can reach out to anyone from the team. We'll be happy to help. Even if you are not a user of Brainboard, our goal is really to mature the security and help teams and companies to build the right way. So feel free to ping me or us anytime you want. So I hope that this session is useful and allowed you to see at least the use case on how to build a cloud infrastructure in a secure way and how to secure it. And also like at least the takeaway that you have now some insight about how to bring some maturity into your workflows. And we are now like 1 hour sharp. I wish you a very nice day or afternoon or evening or morning, and see you the next time. Feel free to ping us. Goodbye.